Hello everyone. So welcome to our new lecture. Now in this lecture we are going to solve question number 7 and question number 8 from practice set 3.1. Okay. So what is the question number 7? The question is, in triangle ABC, bisectors of angle A and angle B intersect at point O. If angle C is equal to 70 degree, find major angle AOB. Okay, so there is one triangle, that is triangle ABC. Okay, triangle A, B and C. Now the bisector of angle A, so bisector of angle A, okay, and the bisector of angle B, so bisector of angle B are intersecting each other at point O. Okay, they are intersecting at each other at point O. The measure of angle C is given, that is 70 degrees. What we have to find? We have to find the measure of angle AOB. So we have to find this particular angle. Now how we can find that? Let us see. So what is given to us? That triangle ABC, okay, it is a triangle, that means we can take the sum of all the angles is equal to 180 degree. We know this property, that sum of measure of all the angles in a triangle is 180 degree. So angle ACB plus angle CAB plus angle CBA is equal to 180 degree. Okay, we know that angle ACB plus angle CAB plus angle CBA is nothing but 180 degree. We have to write down the reason, and the reason is sum of measure of all the angles in a triangle is 180 degree. You have to write down the complete sentence. Now what I will do, I will multiply my equation 1 by 1 upon 2, that is half. Okay, so multiplying equation 1 by 1 upon 2. Okay, that will give me 1 upon 2 angle ACB plus 1 upon 2 angle CAB plus 1 upon 2 angle CBA is equal to 1 upon 2 into 180 degrees. Okay, now half of angle CAB, half of angle CAB is nothing but angle OAB. Okay, this angle CAB is bisected, that means this angle CAO and angle OAB both are equal to each other. Okay, as they are equal, they are definitely half of angle CAB. Okay, so I can write angle OAB in place of half angle CAB. Similarly, I can write angle OBA in place of half angle CBA. Okay, and we have the measure of angle ACB, that is 70 degree. So I will write here half into 70 degrees plus angle OAB plus angle OBA is equal to half into 180 is nothing but 90 degrees. Okay, therefore I will get angle OAB plus angle OBA is equal to 90 minus, now half into 70 is nothing but 35, so I will get 90 minus 35. Now what we get? We get the equation wherein angle OAB plus angle OBA is equal to 90 minus 35, that is 55 degrees. We get the sum as 55 degrees, but this is not our required answer. What we have to find? We have to find the measure of angle AOB. So now I will take in triangle AOB, okay, angle OAB plus angle OBA plus angle AOB is equal to 180 degree. As this is a triangle, sum of all the angles will be 180 degree. We have to write down the reason. Sum of measures of all angles in a triangle is 180 degrees. Now we have angle OAB plus angle OBA is equal to 55 degrees. Okay, so 55 degrees plus angle AOB is equal to 180 degree. Therefore, we will get angle AOB is equal to 180 minus 55, and that is nothing but, therefore angle AOB is equal to 125 degrees, and this is the required answer. That is, the measure of angle AOB is 125 degrees. Now let us see question number 8. The question is, in figure, line AB is parallel to line CD, okay, and line PQ is the transversal for these two parallel lines. Okay, now ray PT is the angle bisector for angle BPQ, and ray QT is the angle bisector for angle PQD. Okay, what we have to prove? We have to prove that major angle PTQ is equal to 90 degrees. Okay, so for that purpose we can write down now, as it is given to us that line AB is parallel to line CD and PQ is a transversal. So here we can use the properties of parallel lines and a transversal. Okay, now we know that angle BPQ and angle PQD, that is this angle and this angle, both the angles are interior angles, and as we have studied that sum of interior angles is 180 degree. Therefore I can write angle BPQ plus angle PQD is equal to 180 degrees. This is my equation number 1. Now I will multiply equation 1 by half, that is 1 upon 2. Therefore I am going to get half of angle BPQ plus half angle PQD is equal to half into 180. Okay, now half of angle BPQ is nothing but angle TPQ. Okay, so I can write angle TPQ plus half of angle PQD is nothing but angle TQP. Okay, so angle TQP is equal to half into 180 is nothing but 90 degrees. This is my equation number 2. Okay, I will write down the reason over here. Now this TPQ and TQP, from what we have got this particular equation, as it is given that PT and QT are the bisectors of angle BPQ and angle PQD. That means they are bisecting the angles in equal halves. Okay, so we can take that half of angle BPQ is angle TPQ and half of angle PQD is equal to angle TQP. Okay, this is the reason behind that, as it is given to us that these rays are the bisectors of the given angles. Okay, now we have got equation number 2, wherein the sum of angle TPQ and angle TQP is equal to 90 degree. Now let us take triangle PTQ. So in triangle PTQ, okay, we can write angle PTQ plus angle TPQ plus angle TQP is equal to 180 degrees. Okay, as we know the property that sum of measures of all the angles in a triangle is 180 degrees. Okay, now we don't know what is angle PTQ, that we have to find. Okay, plus now sum of TPQ and TQP that we have got, that is 90 degree. So we will put here 90 degrees is equal to 180 degree. Therefore we will get angle PTQ is equal to 180 minus 90. At the end we can write, therefore major angle PTQ is equal to 180 minus 90 is nothing but 90 degrees. Okay, hence we have proved that measure of angle PTQ is 90 degrees. Okay, so this was the required solution for question number 8 of practice set 3.1. Now in this practice set we have seen two questions, that is question number 7 and question number 8. Question number 9 and question number 10 of the same practice set is your homework. In the next lecture we will try to understand the congruency between the two triangles. So we will meet in the next lecture. Until then, goodbye.